So I'm the Premier's Research Fellow in Molecular Phenomics, and I'm based at Murdoch University, but my actual job is to take biological specimens like urine or plasma, blood plasma, and to put it into what we call a spectrometer, and that generates a chemical pattern, a fingerprint of all the chemicals in your body. And what that allows us to do is use mathematical equations to model them and look at the difference between people who are healthy and people who have different diseases. So it's all about diagnostics and prognostics, finding early biomarkers of disease. Well, I'm talking a little bit about how I got into my career, which wasn't a straightforward linear path, how I got there, what I like about it, how they can get into similar research fields if they want to pursue that sort of career. So I work in a field called Molecular Phenomics, and it's a new field and it sits at the interface of science and medicine. So what do? Well, if you think of a human, we all know about genetics. This is like the blueprint of what you are and what you can be. So it's encoded into your DNA whether you're going to develop disease, perhaps. Well, perhaps. But are we all getting more obese as a nation, as the Western world, just because of genetics? And the answer is no. Cardiovascular disease, diabetes, even some of the neurodevelopmental disorders, we're now thinking come more from our environment, or at least it's the interaction, the handshake between your genes, your blueprint, what you can be, and your environment makes what actually happens to you, what you become in terms of disease. But there's another player in this story, and we're only just beginning to realise it. Somebody have a go at how many bacteria, or what's the weight of the bacteria we have in our gut, in our stomachs and guts? It's actually 1.5 kilograms. So if you think that's larger than your kidneys, for example. So all these living creatures in your intestines, they are active in terms of they produce chemicals. Everything you eat, we process as a human, but they also eat and process, and they generate other chemicals. So we're beginning to realize that these guys are very important in what we do. Now, when I said I do molecular phenomics, that's a big and complicated word, but a phenome's really simple. The idea is just the measurable physical and chemical features, clinical features. So it's how high you are, what your blood sugars are like, but also all the other chemicals you have in your body that make you you. And no two humans have the same set of chemicals in their blood or urine, and no two humans have the same set of bacteria. So all the bacteria and bugs I have inside my stomach, you'll share some, but you'll have very different ones from me and from everybody else. So I use computers to look for patterns of disease. And in this is an example of a urine spectrum. So if I took your urine and I put it into my spectrometer, I'd get some wiggly lines like this. Now what I can see is some of your human processes. So you've probably all heard of the Krebs cycle or tricarboxylic acid cycle. These are all normal human metabolism, and we pick up signals from that. But in my spectrum, I can also see what you had for breakfast or dinner last night. I can look at this and say, oh, well, that's coming from Brussels sprouts or cauliflower. This one over here is coming from chocolate. So we can see food and what the bacteria have done to it. And these signals here, for example, down here, are microbial metabolites. So humans can't make those based on their DNA and what they're capable of doing. It's the gut bacteria in us that take our food, change it, and then we can then metabolize the chemicals they make. So we've evolved with our gut bacteria. So in general, they're good for us. Sometimes they go a little bit AWOL, and when they get disturbed, they impact on human disease. So we're finding now that a lot of diseases, even autism, even neurodevelopmental diseases, are being affected by our gut bacteria. Not just things like colon cancer, but a lot of liver diseases, diabetes, and early life development are dependent on the bacteria. I love the fact that my job can allow me to make a real impact on human health. I mean, that's the best thing about the job. I also like the fact that the job's very varied and it allows me to travel. I travel all over the world and interacting with different scientists and different clinicians, and yeah, a very, very entertaining, very varied job as well as being useful. Everything, I work at the interface between clinical medicine and science, and everything we do STEM is relevant to. So people have to be numerate, we have to understand numbers, but also have to be able to display numerical data in a form people understand. So we need the more computational side as well as the biology and as well as the maths. What I would say is the most important thing, I think, is to have confidence in yourself. And if you don't get there the first time, just to be persistent, to follow the route you enjoy. And if things go wrong, they go wrong. You pick yourself up and start back again. So I don't think there's any magic to having a career in science or technology. The ideas, the concepts can be difficult, but they're not impossible. It just takes time and persistence.